in this call. My name is Noe, and I'm a Java developer. I've been working with Java for my whole career. So I have a plus 10 years experience. And today I'm going to be talking a little bit about Project Loom, which is one of the future features that will be gradually introduced in the next Java releases. So Project Loom basically is a project that tries to reshape a new concurrency model in Java, right? And I'm going to talk a bit about the history of concurrency in Java. So the first edition of Java came with threads and runnable, right? That was in 1995. And it basically allows you to do parallel programming and concurrency using low-level classes like the thread and the runnable. And it was pretty messy and it was hard to do. And again, this has been in Java since version 1, right? Then in 2004, there were new additions to the Java concurrency package. So it came with the executor frameworks. It also came with other classes that will allow you to manipulate and have a better control on concurrency. For instance, it came with log, reentrant log, semaphores, and all those other barriers, and all those other classes that will allow the programmer to have a much better control on the concurrent on applications. And probably the most important aspect of this new concurrent package that was actually introduced in Java 1.5 was the executor frameworks, which will allow the programmer to create different executors, and it could then submit tasks. So that was a nice way to decouple the concurrent part from the business logic part. Basically, you just had to create your task and then submit the task on the executor framework. And it was a much nice way to implement concurrent and parallel applications in Java. The next improvements in the Java language specification came in 2004 with Java 8. And then here, what was the main point was introduce asynchronous programming in Java. And the main class that was added to the language was the completable future. Completable future will allow you to run a task. You can submit a task in an asynchronous way. And then when the result is completed, you could join and do multiple operations. So basically, it's something similar to Java script promises, where you can actually use this concatenated method and call one after the other to perform multiple actions. And now, in 2023, Java 21 will come with virtual threads, which is a sub-project of the project Loom. And this tries to, again, put Java in a new level, because it will allow to pretty much program in an imperative way using concurrent. That was one of the disadvantages of the completable future. And in general, reactive programming is that you're going to have a lot of problems when it comes to debugging or setting breakpoints, or you know exactly what your application is doing. And Project Loom tries to solve all of these problems. So basically, Project Loom is divided into 3 different sub-projects, right? One of them is, as I said, virtual threads that will allow the JVM to run millions of threads. And basically, the way it works is you have originally in classic Java, every thread corresponds to an operating system thread. Then when you create a thread, that is an expensive operation because it has to, the operating system has to actually create a thread, and then it has to allocate memory, and it takes up to more or less 2 megabytes of memory per thread, plus the objects that the thread is going to handle, right? And virtual threads is a new abstraction, and think of it like a layer that runs on top of platform threads or operating system threads, and is managed internally by the JVM. So platform threads are managed by the operating system thread. However, virtual threads are managed by the JVM, and that gives more freedom, because you can create many more threads. When the thread is performing an input-output operation, that virtual thread can resume, can stop, and it can be released. And then another thread can actually use the underlying platform thread. So that will make that Java will be more, it will have more high throughput and better performance, especially in input-output operations.
So allow me to just to summarize the virtual threads against the real threads. So the real threads, they used to be created by the operating system, so they are cost effective. So in terms of memory allocation, and the operating system has to do some resources to allocate and do. So they are pretty cost. So the idea behind the virtual threads, that the creation of threads and the management of threads, they will not be taken by the operating system. The JVM will take care of them. So it's a big difference between these two things, and I think it's a big achievement for the
Yes,
JVM,
exactly.
that the threads now are, yes. So the threads are
Yes,
now
exactly.
created and managed by the JVM, not the operating system as before. So I think this is like the main difference between this.
Yes, and whenever you're creating virtual threads, you don't need to create an executor, and you don't need to be pulled. So virtual threads are not meant to be pulled like an executor service, where you can create a pool of, say, the number of cores that your system has, your host has, and then reuse them. With virtual threads, you can create as many as you want because they are cheap. They don't consume that much memory, and I think it reduced the memory in order of 2 magnitudes. So we're talking about kilobytes, a few kilobytes. Yeah, and then can be destroyed, and they can be disposable. And whenever you need a new virtual thread, the JVM will create a new one. So they are not pulled, and they shouldn't be pulled, right? So that's mainly for virtual threads. Then another subproject of Project Loom is a structured concurrency, which is currently in incubator. And basically, the main objective of structured concurrency is to provide a way to make synchronous programming with threading in an imperative way, right? And I'm going to show a couple of examples in code. And then the last subproject of Project Loom is scope values. And this basically is in incubator. So that means it's still a feature that will be modified in the next releases. It won't be part of Java 21 in September. So this is something that will probably be finally finalized in 2024 or 2025. Right? And basically, what this does is it is a replacement for thread local variables. And what it allows you, it allows to bind values or objects to a thread, and then they can be shared in different layers of your application. So it works in a similar way as thread local, but it doesn't have the disadvantages of thread local. For instance, thread local is the programmer, the one that has to manage when it is adding objects to the thread local class, and it has to be removed. If you forget to remove it, it's going to keep there the data, and if that keeps growing, then your application may have a memory footprint issue, right? So with the scope values, that's resolved because they are targeted to be used only for a very short period of time, and it is automatically. The JVM also manages the life cycle of a scope value, so the programmer doesn't have to worry about removing the data that is added to the scope value. Once the scope value goes out of scope, it is automatically deleted, and it can be garbage collected. Okay. So those are the three sub-projects of Project Loom.
Sorry, no. Are you sharing your screen, or still you are not sharing your screen?
Yes, I think I did that. Let me just do that again.
Still, your screen is not shared since you begin the talk.
Oh, I will come back. Then now. Can you see my screen now?
Now I can. Yes. Now, if you can just go briefly, just give it a summary briefly. What you were sharing. You were sharing something before this, or you were not sharing before?
Yes, it's the official pages where you can find the project.
Just go in 2 minutes. In 2 minutes, can you just go briefly in 2 minutes? Just revise what we said, because we didn't see your screen. Sorry.
Yeah, so what we're going to look at now is one of the sub-projects of Project Loom, which is structured concurrency. This is still in incubator, so that means that it is not yet a finalized part of the JDK. And structured concurrency is try to model a new concurrent way of programming in Java. And basically the way it works is it provides you asynchronous code in an imperative and procedural way. I'm going to see a few examples now on how it works and what are the benefits of it. Okay. Right. So I've created here a demo in which I have a Java program which is going to basically, the idea is to get the price of a stock, right? And for that is going to call a service. Right? So I have here my service, right? This calls the stock service, and this basically what it does is it's going to generate a random number, and it's going to loop through it. It's going to sleep, sometimes just to mimic that there is input-output operation. So this could actually be a call to a web service or another application to get some data, right? And when the task is completed, it's going to return a value, and it's going to return a record, which is just a name and a price for the stock, right? So if we perform this in a synchronous way, what's going to happen is that all this is going to run in the same thread as the application. So it's going to be a sequential operation, right? Just as normal procedural programming, right?
Yes, sure.
So I can run this. Well, one thing that I didn't mention is that this is currently a preview and an incubator feature. Then if you want to use it, you're gonna have to set your IDE with some settings or some configuration. Otherwise, you will get an error that the incubator and enable previews are not activated. So there are different ways to do that. If you're using Maven and the command line to build your project, you're gonna need to have to pass compiler arguments with enable preview, right? And with the incubator, add the incubator module. Okay, this is if you're using Maven. And the way this works in the JDK is that by default, previews are disabled, right? So that guarantees that you don't make a mistake and put code that shouldn't be there into production. The other thing is that this flag, it must be enabled both on compilation time, and at runtime, right? So again, that's another extra security measure to avoid putting into production code that is not still finalized. So you may compile with enable preview, but then if you run the code and do not specify the enable preview, you're gonna have an exception and a JVM won't even start, okay? And then in IntelliJ, you have to go also, if you're not using Maven and just IntelliJ, you're gonna have to go to the project structure, right? You're gonna have to select at least Java 20 or 19. Yeah, and then in settings, Java compiler, you need to add additional parameters for Java compiler, right? Again, this is for compilation. So with this, you can compile the code. But then if you run the class, it will fail. So when running the class that you want to test, you're gonna have to, again, activate the feature. So you can do that right-clicking on the class, and then modify run configuration. In modify options, add JVM, and it will appear a new test box, and that's where you have to add the enable preview and the incubator. Once that's done, you are all set to use these new features of Java. Okay. And now I have here a second option in which I'm going to call my service to get the stock price in an asynchronous way. If I wanted to do this pre-loom, I would probably have to create an executor service and then submit the task to the executor service. The other option could be to use a completable future. You can create a completable future and then submit the task. And then when the task is completed, you can perform other operations concatenated and call the join method in completable future so that the JVM waits until the result is completed and then extract the result, right? But all that is done in an asynchronous way, right? What we're going to do here is we're going to use the new structure task scope, okay? And another important difference between executors and the new structure scope is the life cycle. When you are using executors, you're going to create the executor when your application starts up, and then the executor is going to be shut down when the application is shut down too, or it finishes. And that's because also executors, they have to create threads, and that's an expensive operation. So you want to have that available in advance, and then you reuse that executor submitting the task whenever it is needed. That doesn't happen with a structure scope because it runs on top of virtual threads. So there's no need to create a pool, right? What the JVM is going to do is it's going to create a virtual thread, and by default, it's going to be run in the common for join pool, which is the pool that Java uses internally for parallelism, for example, when you're parallelizing streams, right? So here what we have is this new structure task scope, okay? And this is going to accept, this is a generic class, and it's going to accept a type, which is going to be the type of the return value that you are expecting. So here what we want is we want to get the stock price. So this is going to be generic for a stock. And the other thing is that this structure scope, it implements auto-closable, so it can be used in a try with resources block. And that's really nice because that means that when the block is finished, the structure scope will be automatically closed for us, and we don't have to worry about managing the resource internally. So I call this an scope, and then inside the try catch is where I am going to be doing my operations. For that, I'm going to use the fork method, and then I'm going to submit the task that I want to. Okay. In this case, is calling the service, which is the same method that I previously mentioned, right? Then the next step is going to be to call join so that it waits for the operation to finish. And the final step is get the value from result now. And I can use result now because I know that after the join, the operation is completed. Yeah. The other thing is that fork is going to return a future object, right? And the future is going to contain our model object, in this case, the stock. So that's just how easy it is to do this. And again, this is going to create a virtual thread for each task that is fork, right? So in this case, I'm just forking one task, and this is going all to be run asynchronously. And as you can see here, there is no code. There is no asynchronous code at all, okay? If I wanted to use, for instance, a completable feature, then I would need to, again, wait for the join and get the result. But I would have the disadvantage that it would be hard to debug, it would be hard to set breakpoints. Here I can set a breakpoint anywhere, and I can debug my application just as if it were synchronous code. Though all this is done from here, all that's inside these trycats is actually run asynchronously, right? It's going to be running on a virtual thread, okay?
It's really very, very interesting. Very big change.
Yes, exactly. Yes.
Yes, it is.
Yeah, but what this tries to do is, I mean, the objective here is to provide a way to work with parallel programming, but in an imperative way, right? That's basically the part. But there is more. There are a couple of more features that come with the structured task scope that are very interesting, and I want to show that to you also. So here I have another scenario in which I'm going to call to multiple services, because it could happen that it could happen that I want to check the stock price for a particular company that is listed in the stock market, but it can happen that I have 3 or 4 different services, right? And I want to call those services and get the value, right? So, but the thing here is that I'm just interested in the first one, right? So basically, I want to call 3 different services, but I'm only interested in the first one that gets me the price, the fastest one, right? Once I get the price from the fastest service, I don't care about the other 2 services, because the price is going to be the same. I'm just looking for the one that is going to be the fastest, right? So for instance, another example for using this could be when you're searching plane tickets, right? When you're searching plane tickets from a destination to from an origin to a destination, you're interested. It may be that the customer is interested in the fastest plane, the fastest flight, or the cheapest flight. So as soon as you get the cheapest price from your different services or your different companies, airline companies, you just done, right? So this is something similar. And a structured task scope provides this feature. In this case, we have to use the shutdown on success, right? And the shutdown of success, what it does is you can invoke or fork multiple tasks, and as soon as the first task is completed, the other one will be cancelled automatically, right? So you don't have to worry about canceling them, or you don't have to worry whether they succeeded or not, or which one is the first one to succeed, right? So in this case, I'm going to submit 3 tasks to the scope. And again, this is done with the fork. So that's actually the same, the first step in this pattern. You do the try with resources where you call your task scope, and then you fork as many tasks as you want, right? The second step is again to call join, because you want to wait for the task. But what it's going to do again here is, as soon as the first one is returned, the fastest one, the other ones are going to be discarded. So that's why I have here, for each task that is submitted, which returns a future, I can check the state of the future, right? And then from the scope itself, you have a method that is the result. You can see it only returns one result, which is my stock, right? So it does that automatically for you. You don't have to worry about which one was the first one and get the first stock that came. No, that's automatically done for you, right? So for instance, if we run this program now, as you can see, the first task that was submitted was successful and the other one failed. And once they failed, those tasks are going to be canceled. So the virtual threads that they are running on, we have 3 different virtual threads. They are going to be canceled, right? And the result that we get in this case, it comes from future A. If I run this one more time, I will probably get different output. Okay, yeah, here as you can see, the first one was canceled, the second one failed, and it was the third one. So the first in this case, the third service was the one that returned the value faster. The other one were canceled, So this could happen if, imagine you have to call 3 or 4 different services, 2 of them are down, the other 2 are up, and you just get the one that is fastest of the 2, and you don't have to worry about any exceptions or anything, right? Here the difference between fail and cancel is because the program runs the try catch, the try block runs very fast, so it doesn't have time to cancel the operation. It just failed, and so it just after the join, when you check the state, the virtual thread, the JVM didn't have time to cancel, it just failed, and that's it. And as you can see, this is all done in try catch. Outside of this, we don't have access to those objects. They are out of scope and they are ready to be garbage collector, and we just return our stock, right? So this is a nice way again to perform asynchronous calls in an imperative way, and we can again put a breakpoint in any of our calls, and we can easily debug. Okay, so that's the stock price. That's one feature that comes with stock with the structure-based scope. And here I have a last example, and in this case I have here another different behavior of a structured task scope that comes by default and is shut down on failure. And in this case, what I want is I want to invoke multiple services, or I want to submit multiple tasks in an asynchronous way. But I'm interested in both or all of them to be successful, right? And if any of them fails, then I want to throw an exception. So this is kind of a little bit of the opposite of the example that we saw earlier. Here, every single task must be completed successfully. If any of them fails, then the operation will be, the overall operation of the scope will fail too, right? And then again, the same pattern here. We use the try catch with resources where we initialize the structured task scope, and in this case we use shut down on failure. And the first step is to submit the task, and again, every of these tasks is going to be running on a virtual thread, so we can submit thousands or hundreds, even millions of tasks in this first step. And the second step is to wait using the join method. And what this is going to be this time is it's going to wait for the two tasks to be completed. If both tasks are completed, then the throw with fail is ignored, and I'm going to return a stock, right? And here I'm just comparing the price and result and returning the minimum stock price that is listed, right? But again, here you can manipulate your data as your requirements, right? So I'm going to run this. Yeah, and as you can see, this time it took a little bit longer than the previous one because it's waiting for both tasks to be completed. In the previous one, as soon as the first successful task is completed, the join is done, right? Operation is done. So in this case, both tasks were completed successfully, and we were able to get the result from each task. But what happens if you throw an exception? Well, we can simulate that. Here I'm going to say that if the random number is even, then I'm going to throw an exception, right? And now let's see what happens here. Now it may throw or it may not throw depending on the, right. Yeah, as you can see here, the whole operation failed because one of them failed, right? So then, again, in this case, it could be used for operations in which that works in a kind of transactional way, where all of them must be completed successfully, otherwise the operation fails, right? And for instance, we can actually do the same with the previous example. Okay. Yeah, and in this case, two of them failed, right? And one was successful. But because that one was successful, our operation was, as an overall, was successful because we were only interested in the first, in the fastest one. The other one failed, as you can see. It couldn't get the, for some reason, it couldn't get the stock price for one of the services. And the other one, they could be both down, but one of them was available, it returned the value, and then the overall operation is successful, right? So those are basically the different flavors that you can find with a structured task scope. But that's not all. You can also implement your own logic. And you can do that by extending the structured task scope, right? So this class is not final. You can actually implement it. I don't have today an example of this, but you can actually extend the structured scope and you can have your own business logic. Let's suppose that you want to say find flights that are cheaper than a specific value. You could create your own task scope, and when you do the get value, let's see. So 1 second here. Let's see. Yeah, when you submit the task and you implement your own structured task scope, you can override a method and you can specify once the return value is available whether it is successful or not. For instance, I could check that the stock price is above $50. So I could put that logic into my own structure scope class. And then it will be just used directly for this one. We will not need to change anything, just using our new class, and the rest of the code would work fine. But it will check our specific business logic. Like, for instance, the expected result, I don't know, the expected result has a specific characteristics. And if that doesn't comply, then the operation fails, or if it complies with those requirements, the operation succeeds. Okay. Yeah. Yeah, that's pretty much all for structure concurrency. So as you can see, it's a very nice way. And another important thing is that you can even have nested structure task scopes. So you could have a method that creates a try catch with a structure scope, and then it calls another method that it can have another structure scope, and it will create all those virtual threads for every task that is submitted, and all done is performed in an imperative way. So you could put breakpoints on the nested structure scope, and you could put breakpoints here on your calls, and you could debug that without, as if it were sequential code. So I think that's all. Not sure if you have any questions or anything you want to comment.
Yeah, I think it's really very, very interesting way of dealing with the the concurrency in Java. It's really, really much simpler, and it's really, really very nice now, well structured, and it's really straightforward without complexity, and using the imperative model also as well. So there are so many advantages regarding easy of debugging, understanding. I mean, it's easy to develop, easy to maintain. Logic is business. You can focus in your business logic, so you don't have to worry about the setup code, after code. So it's really well structured. It's amazing. So for me, I really have no comments, no questions. If anyone else has got some questions, Abdel Nasser. I think he dropped on a question. What about supporting API and microservices? Yeah, I think it can be used in the same way that Noah was calling here the services. So I think you can call other APIs, and also microservices calls can use this pattern to call other microservices. If you have, so for example, I think if you have 5 microservices, you can call these 5 microservices sequentially here in a synchronous way, as Noah demonstrated. I think, yeah, it is supporting, of course. So with that said, with this being said, Noah, do you have any other comments, anything? I think it's really, the session was amazing. I really enjoyed the new Loom project, and I really learned something new because I really didn't know about this new stuff. So I'm really thanks for your presentation. Thanks for the example. Thanks for your time. You have something to end up this session?
Yeah, no, I think that's it. As you said, this is going. It really hides the complexity of multi-threading from the developer. And you don't even, as you can see here, you don't even know that there are threads or parallel or asynchronous code at all. You just write your task, you call them, you wait for them, and then you check whether there was an exception or not, and then you return the value. That's in a very, very clean way. If you had to do this with completable future, you then would have to probably do a call to apply then, or either accept if you want to check one of the other is which one of the two tasks completes or fails, and then extract the value. But again, you wouldn't know, you cannot know for each step, for each call in the completable future where on what thread is running, for example.
Yes.
And then if you want to set a breakpoint or even run a unit test, you can run unit test dist, right? But with reactive programming or completable future, it would be harder to unit test this type of thing, right? Because it may be running on a different thread, right?
Yes, thank you so much, Mr. No. Thank you so much for this amazing session, amazing knowledge. Thanks for sharing this, really. So, guys, thank you guys for joining us to this amazing session about structured concurrency in Java, where No really went us through, explaining since the beginning of the threads in Java, maybe 1.1 till the like maybe 19 from I think 1995, right? 1995
Yes,
approximately.
exactly.
Yeah,
Yeah, every 10
approximately.
years there is some improvement there.
From 90s up to 2023, where he gave us like briefly what are the uh, advantages or disadvantages of each parallel, I mean concurrency or threads programming. Thank you guys for joining us, and see you soon to the next session. So I'm ending the broadcast.
Nice.